Hello students, here we come back with another revision session and it is of work and energy. So the session is divided in three parts. We start with the first part. We start with the concept and definition of work. So we start with what are the important factors in which case we can say work is done. So in case of work done, two objects are involved. One of them exerts force on the other object. For work to be done, following conditions should be fulfilled. A force should act on an object and the object must be displaced. We say work is not done when. Please note, when do we say that work is not done? When force applied is equal to 0 and displacement of the object is 0. Definition of work done. Work done by a force acting on an object is equal to the magnitude of the force multiplied by the distance moved in the direction of the force. Therefore, the formula states work done is equal to force into displacement, that is, W is equal to F into S. SI unit of work done is joules. Definition of 1 joule is 1 joule is the amount of work done on an object when a force of 1 Newton displaces it by 1 meter along the line of action of the force. Then the next part is, remember, work done has only magnitude. It doesn't have direction. Even though this is the case, work done can be positive or negative. So when the angle between the two directions, that is the direction of force and direction of motion, is 0 degrees, the work done is taken as positive. When the angle between the two directions, that is the direction of force and direction of motion, is 180 degrees, the work done is taken as negative. In other words, work done is negative when the force acts opposite to the direction of displacement, and work done is positive when the force is in the direction of displacement. Remember that when the angle between the direction of force and the direction of motion or the displacement is 90 degrees, the work done is 0. So here we consider an example which will demonstrate the conditions in which work done is positive, negative, or 0. So here we can see that the angle between the direction of the force and the direction of motion is 90 degrees. Therefore, the work done is equal to 0. In second case, the angle between the direction of motion and the direction of force is 0 degrees. That is, the force is acting along the direction of motion or the displacement. Therefore, work done is positive. And in the third case, the angle between the direction of motion and the direction of force is 180 degrees. That is, the force is acting in the opposite direction, that of motion. Therefore, work done is negative. Some numericals. Remember, in case of physics numericals, you should have practice of writing down given first. While writing down given, ensure that all the quantities are expressed in SI unit, followed by to find, and then you should start with solution. So here we have to find the work done in flowing the field, where the given condition is force F is equal to 140 Newton, displacement S is equal to 15 meter, and we have to find work done W. So we start with the solution. Here we know that work done W is equal to F into S. We substitute the values, so we get W is equal to 140 into 15. Therefore, work done is equal to 2100 joules. So the final answer is work done in plowing the field is 2100 joules. We consider another numerical where a porter lifts a luggage of 15 kg from the ground and puts it on his head 1.5 meter above the ground. We have to calculate the work done by him on the luggage. Writing down the given quantities, mass M is 15 kgs. Whenever it is the vertical movement, the height through which the object is lifted is the displacement. Hence, S is 1.5 meter. We have to find work done. So here in the solution, you should mention that as the displacement is in the vertical direction, object is under the influence of acceleration due to gravity. Therefore, we get A is equal to G is equal to 9.8 meters per second square. By the second law of motion, we know that force F is equal to M into A. So in this case, it becomes force F is equal to M into G. By substituting the values, we can find the force that is getting exerted on the object. That is F is equal to 15 into 9.8, thereby giving us F is equal to 147 Newton. Now we know the formula for work done. So work done W is equal to F into S. Substituting the values, we get W is equal to 147 into 1.5, thereby giving us W is equal to 220.5 joules. So work done by the porter is 220.5 joules. Here we stop for the first part. We'll continue in the next part.